So, elimination method. Basically, elimination, much like when you eliminate algebraically, involves addition or subtraction. Sometimes we'll add a bit of multiplication in as well. And what the idea is, we're trying to cancel out one of the x's or y's. And we've got x's and y's, or two letters. They can be different letters as well in our simultaneous equation. But we can only solve with a definitive answer when there's a single variable. So we need to get rid of one of them. Okay, so let's have a look at how we can do that. So here is an example which we're going to go through together. We can see we've got 3x plus 4y is 40, 7x plus 4y is 56. Now I've color-coded them, but generally what we would do is we normally refer to them as equation 1 and equation 2, and that can often make it easier. We can use those codes when we want to refer to them. It's also easier when you're describing it to somebody else to say the first and second equation. Now, as we can see, hopefully, the x's are different, but the y's are the same. They're both positive for y. What this means is that because they're the same value, if we subtract them or eliminate them from both equations, we end up with 0. Therefore, there's no more y's. So all we have to do is we take these equations, both of them together, and we set them up as a subtraction. Now at the moment we've got the larger equation on the bottom and the smaller equation on the top. So the first thing we might want to do is flip them over. Oh, don't do that. We want to flip these so that we have the larger equation on the top. So I'm going to take this equation here and I'm going to move it so it's on the top. Okay. And then I want to eliminate them, so all I do, just like when you were in grade 6 and you were doing adding and subtracting, we set them up using column method and we're going to subtract the whole equation from the other. 7x minus 3x leaves us with 4x. But 4y minus 4y leaves us with nothing. 56 minus 40 leaves us with 16. And if we know now that we've got just x's left, 4x is 16, we can divide by 4, and now we can see that x must be 4 in both equations. We can now take that and we can apply it, and we can substitute it in to the equations to help us find the value of y. So we now know x is 4. Now we can choose at this point either of the two equations. It doesn't matter which one you choose. Just make a note when you're doing a substitution which one you use first, because we are going to have to use both equations. So I'm going to use the first one just because it's there. I'm going to put x is 4 into that first equation. The x I'm going to substitute, but everything else is going to stay the same. So I know that x is worth 4. Once I do that substitution, hopefully we can all do 3 times 4, which is 12, which leaves us with 12 plus 4y is 40. So 4y must be 28. If I know that 4y is 28, I can now reasonably assume that y is 7. Now, at the moment, I've only shown that this works in the blue equation. This is called simultaneous. You're solving both equations at the same time. At the moment, you've only solved the blue equation, but we also need to solve the green equation. So we need to take that y as 7, and we need to put them both, x is 4 and y is 7, into the equation that we haven't yet used. We haven't used the green equation, and we must use both. So we can now say, well, I've got 7 x's, 4 y's, they should make 56. So I put in the 4 here. I put in the 7 here. If I do that correctly, I get 28 plus 28. Does that equal 56? Well, yes, it does. So we just put a little tick next to it to indicate that it works. And now we know the solutions. We can give the solutions in two ways. We can either write them as a list, or we can write them as a coordinate. Remember, in coordinates, x always comes first. So First elimination method using subtraction. Let's just briefly go through the steps. We set them up as a subtraction because we had a common variable. We substituted x was 4 to find y was 7. We put both of them into the other equation, so we've used both, and we can give our solution. Now sometimes we'll have equations with positives and negatives. So this one, unfortunately, is a little bit different, but don't worry, it's not much. Again, what we need to do is it's best if we can take them and put the larger equation on the top. But actually, in this case, it doesn't matter, and we'll see why in a second. We've got a positive and a negative for y. When you've got a positive and a negative, the only way we can combine them to get 0 is if we add them together. So instead of subtracting the equations, we add both of the equations together. When we add them, this will give us 11x, nothing, and when we add negative 4 and 26, we get 22. And we can see that x is equal to 2. Now, we could have solved for either x or y first. It doesn't matter which one you use. Okay? I've done x twice, coincidentally. We're going to follow, all you need to do now is follow the same pattern that we did before. We substitute an x, find the other variable, substitute them both in, and solve. Okay? Now, I'm just going to show you another example. Now, I already know the solution. So let's imagine you'd solve for y first. I'm just going to show you how that could have worked. I already know the answer is y is negative 4. So if I put in y as negative 4, I'm going to put it into this equation just to be different because we did the blue equation first last time. 5x minus, now be careful with your negatives, it's 4 lots of negative 4. So that means that, that's a terrible 6. We have 5x. 2 negatives make a positive, so that's plus 16. And then we subtract 16 from both sides. 5x is 10, x is 2. Put in our x equals 2 and our y equals negative 4. Obviously, we're going to do it to the blue equation this time because we did the green equation first last time. And we can see we've got 6 lots of 2 plus 4 lots of negative 4. If we've done it right, that should equal negative 4. We've got 2 here, negative 4, 12 plus negative 16 is equal to negative 4. And if we put that in our calculator, that works. And again, we can give our solution as a list or as a coordinate. So the key thing to remember here was we did addition. Let's get back to the beginning. We did addition because we had one of each side. The most common mistake students make, particularly when they're using addition in elimination method, is not with the algebra, but with the positives and negatives. So just be really careful. If you don't feel confident, use your calculator to check the answer. Okay, finally, you may get questions where at first glance there's nothing shared. Here we've got 1x and 2x, they're not the same. We've got a y and a 3y, they're not the same. What we can do here is something called upscaling. Upscaling is basically where we multiply one of the equations, the whole thing, by a number so that we have a shared coefficient of x or a shared coefficient of y. I'm going to choose to multiply the first equation because it's nice and easy. I've got two options here. We could times it by 2 or we could times it by 3. If I times it by 2, which we'll do first, then that would give me 2x plus 2y is equal to 14. And now we can see that the 2x's are the same. We could, if we wanted to, also multiply by 3. So we multiply it by 3, we get 3x plus 3y is 21. And now we can see that the 3y and the 3y are the same. Once we have one of the coefficients the same, now this could be a positive 3y or a negative 3y. It's the 3 that we're looking at. Same with the 2x, it's the 2 we're looking at, not whether it's positive or negative. Once we've got the same coefficient, we can then use our addition or subtraction. So for this one here, I'm just going to choose, and again, you can choose either of those two. To make it easier, we're going to use this one here, the 2x and the 2y. Again, doesn't matter, I could have chosen either one of them. So we put the biggest one on the top, the smallest one on the bottom, and we can then subtract them. So I'm going to take these, let's pull them out over here. I'm going to subtract them. And again, we can see that leaves us with y is equal to 4. Once you've got one of the values, we can then do some substitution. Now note that we cannot substitute into the new equations we made. Okay, this is because a couple of reasons. First of all, they're not the ones in the question. Second of all, if you make a mistake when you're doing that very first step and you substitute into it, you won't notice your mistake. So again, we just put y equals 4 into either of these two equations. Doesn't matter which. Once you do that, you should get x is 3 and y is 4. Put it into whichever one you didn't use. And then you can either give it as a list or as a coordinate. So just to clarify, upscaling is where you multiply a whole equation, the x, the y, and the number, by something to give you a common coefficient. Okay. Now I've shown you equations that are x and y and a number. You may get ones that are like our graph, so y equals mx plus c, but that's fine. Same methods apply. Then you can subtract them or add them, just like we did before. Substitute, and give your solution. Now, obviously, feel free to go back and jump forward and backward in this video. These examples, I've done a full example of upscaling as well in the introduction notes that I sent to you yesterday, and I've reshared with you today. And obviously, if you're still really missing any of these questions, then you can always drop into the Google Meet, which will be opening up shortly, and I'll be there, and I can go through with you just like I was writing then, and you can see my screen, and we can talk about a question together. So if you have any particular questions, you can just tell me what it is you want to go through, and we'll go through it together. Okay, so I will see you at the Google Meet if you have any more questions. Please feel free to rewind and go through this video again. Use the notes I gave you to kind of go along with it. Hopefully that will give you a bit of structure. And today, solving those questions using elimination method only. We're going to do substitution next lesson. Okay, so please do focus on elimination method today. Good luck, and I will see you later.